So it's okay if you didn't get through them. I just want you to think about it and think about how you would solve this. This first one, did anybody get x equal to 4? Anybody? Okay, yeah, a couple of you did. Now, how would you get that? I'd imagine some of you might have done like 3 times 3, right? You hit enter, you're like, okay, that's 9. Times 3 again, all right, what's that going to give us? I guess it's 27. Times 3 again, like you keep on multiplying by 3s, and eventually you're going to get there. That'll work. Did anyone try doing that method? Just keep on multiplying by 3s? Then you just kind of count up what you get. You can be like, oh, okay, I've got 1, 2, 3, 4, and you get it. Did some of you just type in like 3 to different powers, like 3 to the 3rd, see what you get? Yeah, a couple of you then like 3 to the 4th. Like you just keep on trying different numbers, then you finally got it. Some of you did that, right? Awesome. Did those work? Did those get you the correct solution? Absolutely, they totally did. So this was x equals 4. Here, y, did anyone figure out what y would have to equal? 3, yep. Because 4 times 4 is 16, times another 4 is 64. So if y were 3, this equation would be true. 4 to the 3rd power is 64. And that last one, kind of a big number. Did anyone get that? Z, what's going to have to equal? 8. Fantastic. Good work, everybody. Z is 8. And again, I'm sure you probably did like guessing and checking, right? Or just keep on multiplying. And one of those techniques would work out just fine. That's awesome. That gets you a solution. However, hey, Chromebook's closed. I'm teaching. So that will get you the answer, but it's not a very mathematically precise solution. Normally in math, we don't have to guess and check over and over and over until we get it right. There's usually some, oh, just do this one operation, cancel this out, and get your value, right, to get x. But we don't really have a way to do that here. Like take that one in the middle, 4 to the y equals 64. If I want to cancel that 4 out somehow, what could we do? Sometimes students are like, oh, well, what if you just divide by 4, you know? But does that work here? Not really, because it's not like this will cancel out, because this is like a base. This y is still in the exponent spot. Like, what does that do for us? Nothing really. There's no way to get that exponent all by itself. And that's usually what we do when we solve equations, right? You want to get the variable all by itself on one side by canceling out everything else. But how do you solve for an unknown exponent? We don't have a tool for that. A root? Okay, what about a root? Oh, it's like you're reading into the name of today's lesson. If I did a root, we could do like a y root. Like the index of the root would have to cancel out with the exponent, but without knowing like what y is, I don't know which type of root do I take. Is it a 3rd root or a 4th root or a 5th root? We're not really sure. We'd still be guessing and checking. Turns out there is a technique that allows us to solve for an exponent. And that new mathematical tool that we're learning today is called a log. Dun, 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 dun. Oh, this is very exciting. Today we're going to be working with logs to try to build some cabins. Just kidding. That's silly, Wojcik. Oh, those are so much fun. No, we're not using Lincoln logs. We're using something called a logarithm. We abbreviate logarithm with the word log. Have any of you ever seen this button on your calculator before and wondered, what's this log doing? Is it like how I build a tree? I don't know. So logs are a new operation. So just like we normally have operations for things like adding or for square rooting, we now have a brand new operation called a logarithm. It's going to be a new skill, a new technique that we can use whenever you want to solve for an unknown exponent. Now, the best way to think of this, that's why I have it written up here in jumbo letters, is logs equal exponents. A logarithm is equal to an exponent. Now, the way we use a log, it's okay if you don't get this all down. The main thing I want you to write is this giant thing up here in green letters. In your notebook, write down logs equal exponents. I'm going to keep on referring to that throughout the lesson and throughout the next couple weeks. We're going to use a log to solve for an unknown exponent. Now, the way that it works, though, is you take an equation that's in your exponential form, right? You've got your exponent that you don't know how to solve for, something to the x, and we use a log. But to do that, we have to rewrite it in a new form, in something called logarithmic form. So let's take a look at what log form looks like. And it's okay if you didn't get this all written down. You just need to really get this. As long as you have in your head after today, the logs equal exponents, you're going to be in great shape. So I want you to write down this diagram. Draw this diagram, write the little arrows with the labels and everything like that. On the left, that's something that we've typically seen quite a bit. That's an exponential equation. The form that it's written in, we call it exponential form. How do I know it's called exponential form? Well, because there's an exponent, right? That's how you associate that. If you see an exponent in the equation, we'd call that exponential form. Now, exponential form has three main parts. There's a base, an exponent, and an answer. Now, we're going to use each of those three parts, or those pieces, we're going to kind of rearrange them in log form to help us know how do I use this logarithm. We have to know how do I write it in this other form. So we need to make sure we understand what's the base, what's the exponent, and what's the answer. I always think of the base as like that's the big thing that's kind of holding up the exponent. It's almost like it's got a little hand out there that's raising it up. It's the base, it's the foundation, right? It's strong, it's holding up that exponent. Exponents, we know those are always those little numbers written up and to the right of your number or whatever, right? We always know where exponents are. We use those for years and years. And then you've got the answer, right? That's whatever this is equal to. 2 to some power equals 8. 8 would be the answer when it's written in this equation form. Now in log form or logarithm form, we're going to have those same three parts, a base, an exponent, and an answer, but kind of rearranged. So take a look. This is logarithmic form. Notice there is a base, there's the answer, there's the exponent, but they're in different locations. There's also one more piece to this that we added in, and that's the word log. Well, that's how we know this is log form, because the word log is in it. Exponential form has an exponent, logarithmic form has a log. This diagram is going to be extremely useful to you over the next few weeks, so make sure you've got this labeled very clearly so that you can always refer to it. Because we're going to be swapping between these two forms, going back and forth. Sometimes we want to go into log form, other times we want to go back to exponential form. So we need to be comfortable swapping between these two different equation forms. So the trickiest part about this, a whole new way of writing it, is how do I know where things go? Where's the base? Where's the exponent? Where's the answer piece going to be? Well, the first thing is my wonderful chant that I'm going to keep on saying to you over and over again. And that is that logs equal exponents. So the way that I think of that is when I write a log equation, look at this. This log equals the exponent, right? Because the x was the exponent in exponential form. So whenever you've got log equal to something, that's something, whatever's on the opposite side of the equal sign from the log, that is your exponent, okay? Because logs equal an exponent. Now, what about those other two numbers, the answer and the base. How do you remember where each of those go? Well, this is pretty slick. We know that this is the base, right? It's holding up the exponent. But in log form, that base is written as like a subscript. You know, it's like the opposite of an exponent, how you write it kind of like little low below the line. So I always remember it because the base goes down in the basement. Because it's like down the stairs, like in the base. So the base, it's in the basement. You're going to remember that, you will. Then the last thing we have is the answer, which is 8. Sometimes that's going to be in parentheses. If there's just one thing, you don't need it, but if there's multiple terms, like if it were 8 plus y, well, you want to group that in parentheses to say, hey, this is all part of the answer portion right here. All right? Now, you don't need to write anything down here. This is just me letting you know how we would read this, how you speak this math. So you read it out, log base 3. So you read what the base is, log base 3. You say it just like that. Log base 3 of 9. So you'd use the word of there when you're referring to the answer. Log base 3 of 9 equals 2. And the rest of it's just normal. So log base 3 of 9, that's how you're going to hear me refer to this when you're writing things out in log form. All right, let's practice. Whoops. Writing things out. Oh dear. So let me bring these up a little bit. Got two different equations. That first one is written in exponential form. I know it's exponential form because there's an exponent. I want you to try to write it in log form, okay? So try switching from exponential form to log form. Then I want you to do the opposite. This here is written in log form. I want you to write that in exponential form. All right, so try practicing just swapping back and forth between those two different forms. Perfect. Nice job. Yeah. Yeah, good work. That's good. Yeah, that's it. Awesome. Yeah, so look at like where each of those are and how you rearrange them. Think about where the base goes, where the exponent is. Good. Awesome. Good work. Okay, let's take a look at this first one. That's an exponential form because there's an exponent. To write it in log form, we start by just writing the word log. After you write the log, you got to go down to the basement. And so you look for the base. The base is that strong number that can hold up the exponent. So the base, you write it down there like a subscript. Okay, so it's just a little below that main line where you write things. Log base 3 of the answer. And finally, we know that logs equal exponents. My exponent is a y, so this log has to equal y because logs equal exponents. Now with the second one that's already in log form, we want to write it in exponential form. The way we start is build it from the ground up. So you start at the base. And so I look down in the basement, and there's a 6. That's what we start with. You start with the base. The base then always has the exponent on it. And so recall that logs equal exponents. That tells me that 2 is my exponent because a log equals exponents. So the 2 has to be the exponent. And finally, this will equal h. Which is that answer portion. Anyone get these written the right way? Okay. Excellent. Now, one thing you're going to see often is the term evaluate. You're going to be asked on a question, say, hey, evaluate this log. And you're going to be given something like this, like log base 9 of 81. Hey, evaluate this logarithm. All it means is to figure out what it's equal to. And since we remember that logs equal exponents, in a way it's asking what exponent is log base 9 of 81 equal to. So if you ever see a question like this, evaluate the log, what really helps is to think, okay, well, this equals some exponent. I don't know what that exponent is, so let's just set it equal to x for now. Okay, log base 9 of 81, I'm not sure what it is, but let's set it equal to x. From here, rewrite it in exponential form, and watch what happens. What is the base in this logarithm? It's the 9, right? You look in the basement, that's the 9. And what's my exponent? It's the x, right? I don't know what it's going to be, so we just use an x as like a placeholder. And this should equal, well, the answer portion, the only number left over, is 81. Take a look at this now. Do any of you know what x would have to equal to make that equation true? We know it's got to equal 2, right? Because 9 to the second power is 81. All of you know that. Now, initially, that wasn't completely clear, was it? When it's just written like a log like this. But if you rewrite it in exponential form, all of a sudden, it makes sense. And you can see, oh, 9 to what power is 81? That's going to be a 2. X would have to equal 2. So log base 9 of 81 is 2. So that log evaluates to 2. That is the exponent that log base 9 of 81 equals. Let's practice this. I've got 3 problems for you to evaluate. 3 different logarithms. To solve each of these, or to evaluate each of them, you're just going to want to rewrite them in exponential form. Well, what does that log equal? Like what? Log base 2 of 32 is equal to some number. What is that number? So to help you, write it in that exponential form and then solve it. For the second and third one, you're going to need to think about some various exponent rules that we've gone over this year, such as rational exponents and negative exponents. When you have an exponent, that's a fraction. And you would take the denominator and you can move that, swing that in front to become the index of a root. If I rewrite this first one, 2 to what power equals 32? Did anyone get a number for x? It's just a 5, right? That's kind of like our warm-up that we did today, right? Just keep multiplying 2's, and you say, okay, well, this log evaluates to 5. That one should have been pretty straightforward. The second one, though, if I rewrite this, I start with my base, then my exponent is some unknown value, right? Because this log equals something. I don't know what that something is, but it should equal 8. And that's kind of weird because if I raise 64 to some number, usually it gets bigger and bigger, right? 64 to the squared, it's going to be some giant number. But this equals an 8, meaning it's getting smaller. Now, how is 64 related to 8? What operation could I do to a 64 to make it into an 8 really quickly? Divide by 8 or square root. Yeah, the square root of 64 is 8. And if you recall a certain property of rational exponents, 64 to the 1/2 is the same thing as the square root of 64, which equals 8. So for this one, that log would evaluate to 1/2 or 0.5. So that's a property that we learned first semester. Then this last one, 3 to some exponent equals 1 over 81. Now that's weird because the 3, I could make a 3 into an 81. That was one of our warm-up problems. But it's down in the denominator instead. Do you remember what type of an exponent makes you flip the side of the fraction that it's on? Negatives, sure. So I knew that 3 to some negative number, like -4, for example, I'd rewrite that as 1 over 3 to the positive 4, because then that gets you a positive exponent. 3 to the 4th is 81, so I can write this as 1 over 81. So z equals -4. So that log would evaluate to a -4.